physics video. Yeah, I sort of have something new, but I'm not sure how it'll work out. So, but I'm going to make the video anyway, and I figured I'd do a couple of comments. So the first one was, please explain layman like myself how to push-pull rather than pull blah 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 tides. So it's about tides and how I can convert that into a push. And it just seems pulley, like the moon is pulling. Yeah, it's just even the common explanation sort of explains that the moon is pulling and it's also doing both tides at the same time. I mean, it's pushing the water on one side of the earth in, and it's pulling the water out, so depending on which side of the earth you're on. And the gravity, the earth isn't all that thick, 4,000, 6,000 mile diameter, something like that anyway. Not very thick. So the gravity on one side is pretty much the same as the gravity on the other side. So anyway, but the idea is that gravity goes, most of the gravity, there's a whole lot of gravity, and only a tiny percentage of it gets blocked by whatever it goes through. So as it goes through, it's still gravity. So what's really happening is the moon is shielding pressure from the coming at the earth that's here, right? The moon is here. The moon is shielding the pressure. So there's the pressure on the other side is now not getting compensated by an equal and opposite pressure. So it's still a push. So the tide is being pushed. The water is essentially being pushed off the earth. So it's being pushed from the center of the earth. Obviously it doesn't push it. It just compensates for some of the gravity of the earth. So it, instead of falling at 9 point whatever blah blah blah, the gravity now has a compensating gravity pushing it. Still, the net idea is the water wants to go towards the earth, but it just wants to go there less strongly, if you get my drift. So it's still push. It's just pushing from it goes through the earth and then pushes the outside of the earth out. But obviously the push from the moon being in the way is less than gravity itself. But less gravity means the water will be higher because there's less gravity. It's like jumping higher on the moon. Less gravity means higher. Yeah. So that's pretty much the explanation. You probably you can follow that if you really care to look it up. Like I said, even the explanations of gravity as a pulling force, you'd still get the idea that, oh yeah, well, it's pushing on one side and it's pulling, but it's pulling through the earth. Anyway, all right. So the other comment, your problem still is that light is a wave packet, which doesn't mean anything. It's pretty undescriptive, and there is no wave front. Well, there has to be a beginning to it. Okay, so you can say there's no wave front, but photons don't have a non-beginning. They don't have, they have an identity. They have a place. You can't just say it's not somewhere. It is somewhere. And there is no wave front leaving the slit at the same time and reaching the plane at the same time. Well, I'm just saying the photon, you have to account for the speed of light. So if you're going to say that the speed of light doesn't matter anymore, okay, but that's what you have to say. If it's going through both slits, okay, I mean, again, I just make the argument that this different length of path here has to be accounted for. And you can either draw two conclusions. You can either draw the conclusion that the photon actually goes through one or the other slit. You can either draw the conclusion that it goes through the longer path slit, and that's the actual speed, and that this other information that's conveyed to it, this other compensating interference with itself, yeah, is somehow moving a little slower than the speed of light because it's traveling less distance but getting there at the same time. I'm just saying you can't pretend that it doesn't matter, that it has to be the same timing. Regardless of what the phase is, it has to be there at the same time. And you can understand that in water waves because the medium is controlling how fast the waves move. There's no medium presumably here, and if there is a medium, it is the speed of light medium. So again, you still have to explain how it happened that way, how it can happen that way with light. So anyway, which I don't think you can do without creating a medium. I said it months ago, I say it again, your model does not account for destructive and constructive or out of phase and in phase action of waves interference. Again, I don't have to, because I don't think it's a wave interference, so why would I have to do that? All I have to do is account for a filtered pattern, okay, that reflects the fact that, like all these patterns, they're based on some sort of mechanics. What causes regular wave dynamics? I mean, look, another thing about this whole theory of yours is that light comes in at nice straight waves and it leaves here in little bulges. Okay, now you know the explanation. You have no explanation for what's causing that. We know what causes it in mediums. Okay, is that there's this thing called like friction and tension. You know, water has tension, and so this area this ends up creating a bulge in water waves because there is a slowing down of the progression, the momentum of the wave through the medium. When it goes next to a surface, it's changed in terms of how it migrates through it. It can't go through it as a straight wave, but light could, because light can't be bothered with friction. So again, you don't have any explanation for that at all, none. You're just saying it. Oh yeah, well it's acting like it's a wave in a medium, and yet you're not going to explain the medium at all, and why it has something called friction in it, when nowhere in any dynamic of light do we understand it to be bothered with such a thing as friction. What's the other thing I wanted to point out? So again, all I have to do is explain why there's something similar happening in light. So you're getting a similar pattern, the same ratio of pattern. But that's sort of what I wanted to explain here, is that we have this idea that these waves you know, combine so that you end up with you know, the regular wave would look like this, and because they've piled on top of each other, the wave ends up looking like this. So it is the deep, you know, the peak is twice as high and the trough is twice as low. So this is another thing you can't duplicate in the two-slit experiment, where you could in a wave experiment, right? By just synchronizing the wave, you could, depending on where you put the target, you know, depending on how close the target is, you could change the location. Now, you can't change the location of the peaks and troughs. Yeah, they're just doubled. Right. Okay, but anyway, so you end up with this idea that, okay, but there's these direct, the dead spaces, okay, so the target's here, and it's these dead spaces, okay, that we're really concerned with, okay, that let's say they show up here. And so this is your peak, and this is your second peak, and your second peak. And that's happening, you know, that this coming down, and it is happening at the source. So again, it's not like you have to, it's not like the information isn't known right down here. I mean, the information is known at almost the origin. I mean, shortly after the origin, the two little waves are way down here, and it's already established what's going to happen here, back here. And it's just a matter now of deconstructing it further down, further back, to figure out why exactly this happens. Right? These places where the momentum or energy of this part of the wave, this section of wave, right, this whole section here, has been the strength of it has essentially been contributed into here. So that these sections have their energy. These dead spaces have essentially given their energy to these spaces. So this arrow would go the other way. And you know, that's accounting for, you have the same energy. It's just that you have the energy showing up, you know, as a, you know, higher peak to trough ratio. So that's what you really have here, is the higher peak to trough ratio. The troughs are lower and the peaks are higher. And this one is just dead. It's just, there's no peak and there's no trough. Yeah, so it's not like you have a true bottom. You have a neutral and then an exaggerated peak to trough, which, again, if you convert into light, doesn't make much sense. Doesn't make any sense in my opinion, because you're stuck with some sort of half a photon thing. Anyway, you know, the no photon being the unphoton, I don't know. You can't even say that. The double photon being the unphoton plus the double photon. Something like that. Well, anyway. Alright, so I'll just get to what I have been thinking about as an explanation. So I was thinking, you know, which I didn't account for before, but you know, everything creates an EMF, you know, an electromagnetic field around it. So everything ends up getting a charge of some kind. And the question is, what charge does it get? You know, is it positively charged or negatively charged? And you know, there's a field that's created around it that is immutable to orienting things that come in contact with the field. So in a sense, if something's coming into an electric field, it's going to tend to align with the field until it hits a neutral location. Then it may just stop moving, because the pressure will be even on it in all directions. So, you know, it's like well, I'll just go to the picture of that, and then you can sort of get some of this. So with magnetism, you know, here's some field lines. So this is a dipole. That means like this is plus, this is minus, or vice versa. And this is where both of them would be minus or both of them would be plus. And this is another thing about field, you know, that's sort of curious, is that the interference lines in water waves also have this hyperbola. I think it's called a hyperbola. They have this hyperbola effect. So that is sort of a coincidence. I didn't think about that, but there is this hyperbola, and there's these field lines also have that kind of geometry. So there might be something quite similar there. And you can just see from this image that either way I go, that is with monopole or dipole, you know, I don't know what I just don't know what the electric, like if I have a two-slit experiment, what exactly would happen. Would this be plus, this be minus, this be plus, and this be minus? You know, this surface here, I'm just talking about these surfaces in terms of their charge. You know, or could this center one be like a monopole and these are just both plus? So that's a little, I just don't know. You know how the electric field would even out when you just cut two slits out of something. So I have to do the math for that, or I have to find the math for that and figure it out, because I just don't know the answer off the top of my head. You know, it does get kind of confusing, all this field line stuff. So anyway, here's the magnetism thing. I guess we just look at that. Alright, so this sort of indicates that there's these lines, but they're not really there. The whole thing is a consistent stream. I would argue it's just, you know, by my theory, it's just a consistent stream of photons, you know, gravitons, polarized gravitons shooting out. and that these things are just aligning where the pressure from both sides is equal. And that's how they line up. They line up in alignment with a evenness of pressure. But they are, if they're magnetic at all, becoming magnetic, they tend to want to go somewhere, but they're essentially interfering with themselves now. So once they start establishing positions, everything just jockeys for that position. So that's why when you shake it, this pattern, it just doesn't, the pattern just doesn't show up. You kind of have to create some noise that'll force things to establish themselves in these positions where the charges are equalized out. Because essentially what's happening is all these filings are turning into mini magnets, and so they're creating the separation between each other. So it's sort of an artificial separation. It's not a real field line. It's just what will be established as the proportional relationship that'll have to exist between them. So they'll just adjust as they fill the space to the density of the field they're creating by existing in the field. So if you had no magnets over here, you would likely change some of these peripheral field lines would line up differently if you didn't have any mass in certain areas. What I'm arguing now is that this pattern is a curious one. This fact that it is a hyperbola, it is an arc that's much like a wave front. And more specifically, especially coming out these ends, and that this might be the source of the mechanism through diffraction, because you'd figure, say if it was doing this thing between, so say this is the slit, and this would be the relationship in a common dipole, so this would be the south side, and this would be the south. That's weird. Well, anyway, this is one side would be north, one south side would be south. I'm just trying to figure out how you cut this in two. This would be north, this would be south. Yeah, that's it. So just think of it as two magnets, and that they would establish these field lines to each other. And this is essentially what you have here. These are essentially, one magnet is essentially two magnets in terms of this middle area. But anyway, the point would be is that you can kind of see that it's kind of like a circle, and that when light comes in, if it goes right through this middle part, there's no diffraction, but you can clearly see that as it goes through these other parts, it's going to start. See, the thing you got to understand is when there's a field line, what stuff wants to do when it goes through one is it tends to come out perpendicular to the field line. That's where the forces are even. So it's always going to be pushed to that perpendicular. So no matter what angle it comes in, if it even comes in at kind of an acute angle, it's going to be pushed towards that perpendicular. That's always going to be the place it's going to be pushed to. So you can see if it goes through multiple field lines, and it always leaves being pushed towards the perpendicular, that the more it goes through, like say it went through here, it might come out here, a little bit off, and then the next time it's going to be a little closer to the perpendicular, and the next time be a little closer to and eventually it's going to come out totally perpendicular. So I have to work out the mechanics of that, but that mechanism in itself, might tend to, depending on the wavelength of the light, tend to to separate into clump. That's the right word to say. Filter. Might be a cause of the effect. You still have to account for the change that takes place. So what I'm sort of arguing is that when you have the one slit, let's say just the twice the wavelength of the light, a slit that width, and then you put an impediment in the middle, you would create a change in this field. So if I took this example, this dipole, and just put something right in the middle of this dipole, I'm going to completely change this pattern into, you know, one with two indices. And then another problem with thinking about this was the idea that, you know, all the light that doesn't get to the that doesn't go through the slits, hits this stuff. And as it hits this stuff, it creates an EMF, you know, an electromagnetic field. It energizes, quote unquote, the substance through the absorption of light. I mean, certainly it happens with a lot of metals where they actually create an electrical current that's perceivable. But even if it's not a perceivable current, it could be changing this field. And so that could be another explanation for the difference between, you know, one slit and two slits, is that these patterns are changed in a way when there's two slits that you know, change the arc of these patterns. So like this bulges way up. You kind of get the idea that if you have an eccentric field, that it may have these areas of crossover. Draw on there. Bad, Gary. That's really dumb. Anyway, didn't even realize I was doing it. It'll clean off. So anyway, just want to get rid of that while I'm sitting here. I have some vinegar here. Try that. Oh yes, very nice. Okay. Sheesh. Sometimes you do the stupidest things. Anyway, no, it's not that stupid, but it's very stupid. So anyway, that's what I'm sort of working on, is a theory of that. But I think the real thing that I want to do is more clearly understand why water waves do what they do, in the sense that you can trace this all the way back. Like I said, this interference, this dead space, it starts right at the beginning of the interference pattern. I mean, as soon as they interfere, this is where this inevitability is created of the space where there's, you know, the dead spaces, and how exactly through the overlapping of a wave you end up creating the constructive part. Because the constructive part is really all there is, right? I mean, you don't have a destructive interference unless you have constructive interference. You can't have one without the other. Is essentially one is being made out of what would be the force, what would be the energy of the other. So I don't think there's any such thing as constructive interference without some destructive interference to create it, just as there isn't a positive without a negative being created. So in that sense, just as electrical fields are completely dependent on creating something by creating something, you have to have one to have the other. You have to have the plus to create the minus, and the minus to create the plus. You have the same kind of thing is happening. The same kind of rule exists here with this constructive and destructive interference. So I just need to find a way to converge this into converge this polarization idea and this field effect into a model that demonstrates how it becomes this you know, how this functional pattern of, you know, 4 2 0 kind of how it works, you know, how the it's the height thing, so it's 4 2 0, yeah, and then 4 2 0. Anyway, I'm just trying to relate it also to the glass reflection thing, because it has the same ratio based on how photons reflect through glass. The rate they reflect is by the same, ends up creating the same sort of pattern. So anyway, Now, in other news, I have messed around a little bit with this fiber optic stuff. And in theory, what I'm saying basically is that these little tubes are really small. And the real catch for the two-slit experiment is creating this little tiny impediment and then having the two slits, right? So it's always, like I said, it's always kind of drawn incorrectly because they always draw it with a large impediment. And it's really a tiny, the middle impediment is usually 1/10 of the size of one of the openings. So it's more realistic to draw it as the small impediment, you know, experiment. But anyway, yeah, so the idea though is that, you know, with sound, and I saw it done with radar, but the radar experiment was very iffy, just because they used a modulated, you know, a tone modulated 16 gigahertz radar signal, that it was carrying a tone, and so you can't be sure whether it was the tone that was interfered out or whether the radar itself was creating the interference pattern. So I don't think the radar actually doesn't show up somewhere. What's happening is that the radar signal isn't interfering with itself, that that the thing it's carrying is getting interfered. So it's not it's a really tricky example because, you know, when you put sound on photons, you know, that just confuses the two subjects, because the sound, you know, is a frequency on top of another frequency. And clearly in sound waves, we're still talking about a medium. Not that the sound that's modulated on photons is a sound wave anymore, it's not. But it still has a phase. And so the receiving signal, its amplitude, so if the signal is being amplitude modulated, that means the radar gets stronger and weaker, then obviously you're kind of corrupting the experiment, because you're sending the radar out at fluctuating frequency, amplitude. So it's not a constant, consistent stream. And so you can sort of understand that it'll just be about how high the amplitude of the wave being carried, the sound being carried on the radar. That amplitude is what you're going to be reading instead of the strength of the radar signal. I think you probably could understand that. So I'm just saying it gets a little complicated when they start messing with signals where they're not just detecting the existence of the signal rather than the existence of what they put on the signal. The existence of the photons rather than the amplitude of the photons, the amount of them. So that's why, you know, the experiments I see done with radio waves and radar are corrupted by the fact that they're using the radar as a carrier, and they should just use it as a field and then just measure the strength of the field. So anyway, the point being is that, say if you take something like radar, you can have them like, you could have the two sources, the slits, so to speak, you know, 7 or 8 centimeters separated, you know, the sources, because your wavelength is now large. You know, it's like I guess a 16 gigahertz signal would have a wavelength of like 7 or 8 centimeters. So it's, you know, it's like that. And so now you can separate the signals and create your interference pattern, theoretically, with a much wider gap. So the bigger the wavelength, the larger the separation, where you can still create your interference pattern. And, you know, so it's kind of easier to work with if you can work with these slower wavelengths. And but the idea I was thinking that, okay, so if that were true, if they're actually getting an interference pattern with photons, real photon signals, not sound, but radio or radar, and it's really in the radar, where the photons of the radar are being interfered with, which, again, see, that's the corruption of these experiments. But anyway, the whole point would be is that the source is what's important, and how close the sources are to each other. So the idea with this fiber optics is that you can have the two sources really close. So you can get the sources really close to each other using fiber optics, and then you should technically be able to create the interference pattern, because the two sources are within the required distance of each other to create the same pattern. But I guess that's the trick of it, is the fiber optics need to still go through an aperture of some kind. So you have to create a lens at the end, an aperture, to create the fanning effect that takes place, because the slits are smaller than the wavelength of the light. So, as you make the slits smaller, as you move the slits tighter and tighter, the pattern gets wider and wider. So that's kind of the weird thing, is that the pattern is less when you have a big slit, and when the slit gets smaller, the pattern goes wider. So that's the non-intuitive, weird thing. That, in my opinion, isn't weird, because by my theory, as you move the slits closer together, what's really happening is these field lines end up getting closer and closer, and that means your likelihood of hitting the strong field lines becomes higher and higher. So you're getting, the field is always stronger closest to the source and gets weaker as you go out. So the closer you move two things together that have an electromagnetic field, the stronger, the more likelihood the thing you're sending through is going to hit the strong field. And so that's what's creating the diffraction, the separation, is the fact that the photons are now more likely to go through the strong field, where when you have them further separated, the fields are like this. So the thing, the field lines have limited range. They fall off, 1 over r squared. So most of the light ends up unmolested, and that's why you end up with the blurrier pattern, is because most of the light gets through unmolested because the field is smaller. So what I'm sort of arguing, I think in a way, is that when you inject the middle impediment into the slit, into the big slit, let's say if you just had a big slit and then you put the impediment in, and now you have the two-slit experiment, what's really taking place is you're magnifying the strength of the field and making it more probable to have the interference with the field, so you're spreading the light more for both apertures. And similar to, like this slit could be considered to be similar to what happens when you put a core inside of a coil. So if I have a coil and I put a core in it, I completely change the electrical dynamics of the electrical field. I increase it substantially by putting a core in it. And the slit is maybe acting as a core, which is ending up magnifying the strength of the electromagnetic field. Yeah. Alright, I think that's enough of a... And it's not, again, it's not the field that's bending the light, so let me just make sure that's understood, because I don't think fields can do that, because I don't think fields are fields. Fields are gravitons. But what I'm claiming is happening is, just as in the magnet example, what's happening, yeah, don't write on it this time, is that all the little subatomic particles in the atmosphere are just floating around in a non-perfect vacuum. All the ions and whatnot, they're the things filling up these field lines. So just like these metal filings that make it easy to see, even if these metal filings didn't exist, these field lines would tend to collect atomic particles in exactly the same kind of pattern. The ions would all tend to fall into these patterns and create these little magnetic effects that would establish the same kind of pattern. So what's happening is when light's going through, it's hitting these charged particles, these electrons and maybe some protons and other kinds of, half atoms. You can have all kinds of, like, you can have high hydrogen atoms that don't have an electron. They're just a neutron and a proton. That kind of thing, negative and positive ions. And the photons are interacting with them, okay, because that's what photons interact with. They interact with atomic particles, the pieces of atoms, the electron or the proton or the neutron. That's what they're interacting with. And so even when we just said electrons, there's a bunch of electrons establishing existences on field lines. And so that's what the photons are interacting with, is the higher density of electrons on these lines, these established lines. And those lines are creating the necessary geometry that's obliging directionality. But like this is going to take some math. Clearly the variables are all the same, so this is, you can end up, all you're really talking about is the distance of the slit, the distance of the impediment, and the wavelength of the light, and position of the electrons would be the only thing I'm adding. So I'm adding this wave, so to speak, as a variable where the current physics is saying the wave is part of the frequency of the light. I'm saying the wave is here in the structure of the material the light is interacting with. The density of the electrostatic particles, can I say that? Electrostatic particles that the light is encountering as it travels through the slit. Alright. So some of you might have followed that, maybe. Anyway, so still working on it. I got other stuff to work on, but anyway, it's I gotta step it up. I got so much to do. But I'm liking this idea. Just that I hadn't thought of it before, about this idea that the field lines do tend to establish the shape necessary, to create these structures. And I also like the idea that this is a whatever that word is. Oh shit! What the hell? Oh, I did draw on it again. I can't believe I cannot use that pencil. Look at that. That's terrible. What am I, insane? That must be insane. People have been saying that for years, and I was doubting it, but this seems like insane behavior to me. Okay, it just comes right off. Gee, that is really stupid. Do not use the mechanical pencil as a pointer. I have things here I can use as pointers. I have something. Where would a screwdriver? Well, that wouldn't be too good. This thing, a stylus from a really old tablet. Yeah, so I can use that as a pointer. It's harmless. All right. Anyway, I think that's enough. Probably could use a laser pointer, couldn't I? Let's see. Yeah, it works. Yeah, I could just use a laser pointer. Yeah, I have to remember that. Alright, see, but these lines have that hyperbolic? No, well, whatever that shape is. A little bit curved and then goes straight. That's what it is. I can't remember the name of that. It's not a parabola, but a parabola is this clean thing. It's not as it's crookedy and then straight kind of thing. Anyway, till next time.